Now that we know what's the mathematical model that we want to solve, governing equation and boundary conditions, i.e. a boundary value problem, let's take a look at how to solve it numerically using the finite element method. So I'm moving from talking about the mathematical model to talking about the numerical solution procedure and how through the numerical solution with the finite element method one can calculate selected variables at selected points. The first thing we do is discretization. Let me unpack that idea. We reduce the problem to determining temperature values at selected locations. That's the bar I have, and I need to determine the temperature along that line. I've reduced it to a one-dimensional problem, so I need to determine temperature only along a line. So I need to determine the function t of x. And I say, you know what? Instead of determining temperature everywhere along that line, I'm going to determine only at selected locations. In particular, I'll determine it at 4 locations. 1, 2, 3, 4. And everywhere else, I will just use an interpolation. So if I want to know the temperature here, I'll use an interpolation between that value and that value. If I want to know the temperature, let's say here, I'll use an interpolation between that value and that value. It's a linear interpolation. So which means that if I plot the temperature versus x, okay, and these, are my 4 values, then in between, it's just a linear interpolation. I don't know these values yet, but I know the shape. The shape is going to be that. So I've reduced the problem to determining temperature at 4 points. So instead of determining an unknown function, I'm going to determine 4 values. That's called discretization. And it's easier to determine, a finite number of values rather than a function. Determining unknown functions is hard. Determining a finite number of values is not as hard. And in terms of terminology, these are called nodes. Okay, that's what I have here. And these are called elements. So I've divided my domain into 3 elements. And I have 4 nodes. And in the process, what we have done is we have assumed a shape for our function, and that shape consists of piecewise polynomials, piecewise linear polynomials. And these, the shape is constructed element by element. And in any finite element, methodology, you do that. You're assuming a shape, and the shape is constructed element by element. The crux of the problem now is how to determine the temperature at the nodes, in our case at the 4 nodes. Let's talk about next.